Today's lesson is on simplifying rational expressions. Remember a rational expression, rational coming from the word ratio. So basically we're going to be simplifying fractions that include variables. And that's our objective for today. So first of all, a rational expression. As we've talked about, it is a ratio. Of two polynomial expressions. So examples here, we've got 1700 over d minus 33. So you can see you can have a constant involved as far as 1700. The next one here, x squared over 4x minus 3. So again, the x squared, you can have any power of x as long as that's an integer, a positive integer. This third example here, we've got a quadratic equation over a linear factor on the bottom. This third example, we are dividing two quadratic expressions, both of second degree. And this third one is again a quadratic divided by a linear. So today we're going to work on simplifying these rational expressions. And to do that, you're going to divide the numerator and denominator by their greatest common factor. So in other words, we're going to factor everything completely and cancel out complete factors. Now, we've spent a lot of time factoring this year. Hasn't been the easiest concept. But remember our steps. Step number one, always take out the greatest common factor. Step number two was to look for difference of squares or possibly sum and difference of cubes. Now in this chapter we will not have any problems dealing with sum and difference of cubes. And then our third step we did was factoring by trial and error. Now we did some other things like grouping and rational root theorem in order to factor, but this lesson will not go that much into detail. Okay, just some examples on simplifying rational expressions. So in this first example, we're going to look at this and try to factor everything as completely as you can. That top expression is a quadratic. It's not difference of squares. It's not a PST. So I'm going to try to factor that by trial and error. I got to have x and x. I'm going to have one of each sign because it's a negative. Factors of 4 that add up to a positive 3. I'm going to need a positive 4 and a minus 1. Now, therefore, these complete factors are the same. Those could be canceled. And I would be left with just x plus 4. Now, your assignment today is going to deal in IXL, and they don't talk about this, but we should always say what it is defined for. And then in this case, if the bottom is 0, it would be undefined. So what makes the bottom 0? A positive 1. So x cannot equal a positive 1. But as far as just simplifying it, it would equal x plus 4. This second example here, you can see we've got two quadratics. So we're going to factor both the top and the bottom. X and x, we need one of each sign. Factors of 6 would be 3 and 2. I need a positive 3 and a negative 2. And you're checking your insides and outside terms. All right, now in order to simplify these, we've got to realize that we're only doing this if we can cancel things. So thinking about this and looking at the bottom, you can kind of use the problem to help you solve this. So I'm going to deal with x and x. And now looking at the plus 15. Both signs got to be positive because of the positive 8. And then the only thing that would cancel is if I have a 3 here. And if I have a 3 here, I would need to have a 5 there. Does it work? Yes, it does. So then your x plus 3's would cancel, and your final answer would be x minus 2 over x plus 5. we would say x cannot be -5 because that makes the bottom equal 0. Next example. The top there you can see has two terms. It's separated by a minus. That's difference of squares. That was always an easy one for us to factor. It'd be x minus 5, x plus 5. And then again, we should be thinking, are any of these going to be factors of the bottom? Well, first step, greatest common factor. If I take a 3 out, I'd be left with x minus 5. So therefore, my x minus 5's cancel. And I'm going to be left with x plus 5 over 3. The bottom can never be 0 because it's always 3. So that's our answer. Next example, we got 50q on the top, not much I can do with that. On the bottom, I've got, again, greatest common factor. I could take a q out of those, which will leave me with q minus 6. Then I could cancel these q's, and I'd be left with just 50 over q minus 6. Q cannot equal a positive 6. A couple more examples. These are kind of directly out of your IXL assignment. The top one here, again, the bottom is not going to factor, z minus 11. So what I should really just check is if z minus 11 is a factor of the top, because that's the only way I'd be able to cancel something. And if that is, I would have to have z plus 4. Checking this, I've got a negative 11z, a positive 4z. That does give me a negative 7z. It does work. I'd cancel the z minus 11s, and my answer would be z plus 4. The domain here, what makes it undefined? Anyone have this answer for me? What would make the bottom equal 0? What would make the bottom equal 0? Alex, you got that answer for me? 11. Yes, 11, correct. Well done. So z cannot equal 11. Next problem here, we've got a quadratic divided by a quadratic. I'm going to start dividing here. The top, I'm going to have c and c. I got a positive 18. My middle term is minus. Both signs got to be negative. Factors of 18 that add up to 11. 9 and 2 is going to work. All right, and then, looking at the bottom, the only way this is going to work out is if either c minus 9 or c minus 2 is a factor. 9 goes into 36 4 times. Don't think that's going to work. But 2 goes into 36. How many times is that? How many times does 2 go into 36? Isaac? Yes, correct. Well done. And that's 18 times. So that'd be a positive 18. All right, so now these c minus 2s would cancel. I'd be left with c minus 9 over c plus 18. And then, as far as what makes it undefined, c would not equal. Who's got this one for me? C could not equal. What makes the bottom 0? Bottom 0. Yes, correct. C cannot be a negative 18. All right, so that is simplifying rational expressions.